Enthalpy is used to quantify the heat flow into or out of a system in a process that occurs at constant pressure. The change in enthalpy equals the enthalpy of the products minus the enthalpy of the reactants. Enthalpy is a state function. The change in enthalpy equals the heat given off or absorbed during a reaction at constant pressure. Is delta H negative or positive for the reaction of methane plus oxygen to give CO2 and water? The system gives off heat. It is exothermic. Delta H is less than 0. It'll be negative. 890.4 kilojoules are released for every 1 mole of methane that is combusted at 25 degrees Celsius in 1 atmosphere. The reaction is shown, and the delta H is a negative, meaning heat given off 890.4 kilojoules per mole. Is delta H negative or positive? Here we have water solid being converted into water liquid. In order to do that, heat has to be absorbed. The system absorbs heat. It is endothermic. Delta H, the change in enthalpy, will be positive. 6.01 kilojoules are absorbed for every 1 mole of ice that melts at 0 degrees Celsius and 1 atmosphere. The stoichiometric coefficients always refer to the number of moles of a substance in thermochemical equations. The conversion of water solid to water liquid has a delta H equal to 6.01 kilojoules per mole. If you reverse the reaction, the sign of the delta H changes. Water liquid becoming ice, water solid, delta H is a negative 6.01 kilojoules per mole. If you multiply both sides of an equation by a factor n, then delta H must be changed by the same factor. 2 moles of water solid becoming 2 moles of water liquid will have a delta H of 2 times 6.01 or 12 kilojoules. The physical states of all reactants and products must be specified in thermochemical equations. If you look up the value for solid water becoming liquid water, it's a delta H of 6.01 kilojoules per mole. But if we convert liquid water into gaseous water, that is the vapor, notice that the delta H for this process is 44 kilojoules per mole, so it clearly depends upon the state. The specific heat of a substance is the amount of heat, Q, required to raise the temperature of 1 gram of substance by 1 degree Celsius. The heat capacity, C, of a substance is the amount of heat, Q, required to raise the temperature of a given quantity of the substance by 1 degree Celsius. Here's a table of specific heats. C, the heat capacity, equals the mass times the specific heat. Heat, Q, is absorbed or released. Q, the heat, equals the mass times the specific heat times the change in temperature. Or, if you have the heat capacity, it's simply the heat capacity times the change in temperature. Remember that the temperature is a state function. You need to know only the initial and the final temperatures. Here is a picture of a constant volume calorimeter. Here the system is isolated in a bucket of water. The temperature is controlled. The heat is released when the reaction takes place, and the temperature is read by the thermometer. Here, Q of the system equals the heat of the water, the heat of the bomb, and the heat of the reaction. Since the system is isolated, Q system equals 0. Therefore, Q of the reaction will equal the negative of Q of the water plus Q of the bomb calorimeter. Q of the water is mass times the specific heat times the change in temperature of the water. And Q of the bomb is equal to the heat capacity of the bomb calorimeter, which is a given, times the change in temperature. At constant volume, delta H does not equal Q of the reaction. Delta H is approximately Q of the reaction, the heat of reaction. More commonly is the constant pressure calorimeter, which is used in chemistry. Here's a simple one using just an insulated styrofoam cups, a thermometer, and a stirrer. Here Q of the system equals Q of the water, Q of the calorimeter, and Q of the reaction. Again, Q of the system equals 0, so Q of the reaction equals the negative of Q of water plus Q of the calorimeter. Again, Q of the water equals the mass times the specific heat times the change in temperature, and Q of the calorimeter is the heat capacity of the calorimeter times delta T. At constant pressure, in this case, the change in enthalpy does equal Q of the reaction.